Really is a big honour for me to address you this morning on such an important topic as fire safety. It's so important to our industry, so thank you for that. So I'm responsible for innovation and product development at MEDITE Smartply. We produce a range of MDF and OSB products, and what I'm here to talk about today is specifically wood panels with flame retardants inherent to their production. So a very brief overview of my presentation this morning. By way of introduction, what I'm going to do is we have a number of different products in our product range which cover FR. In the interest of time and clarity, I'm going to just focus on one, which is flame retardant OSB for structural use in construction. And the specific reason I'm doing that is because it calls out a number of key aspects of the CPR, the Construction Products Regulation, which relate to the product performance. I'm going to go into a little bit of detail, not too much, you'll be glad to hear, on the CPR and specifically what our obligations are as manufacturers. I'm going to give you a very rare insight and glimpse into our product development. We don't do this generally, but I think today is a good opportunity to do that without divulging any trade secrets or anything like that. But I do think it's important for you to understand there are companies who invest heavily in R&D, specifically for the reason of ensuring the performance of our products and the safety of those products in use. And then it's all very well doing things at an R&D scale. The most important thing is the ability to upscale that to plant level. So that means basically taking the prototypes that we've developed in the R&D lab and putting them into practice in a real full-scale manufacturing process, specifically looking at quality assurance testing and the type of formal testing that Gordon just alluded to there in terms of the Euroclass, and I'll also cover a little bit of detail on the STA, the Structural Timber Association FR Build program as well. I'm going to spend about 5 or 6 minutes looking at CE marking, because that is the crux of it here. That's the crux of the information we're looking at here is our obligations as a manufacturer, the harmonised standard that covers wood panels, and our obligation under the CPR to CE mark the product, and how we test the product and how we then achieve independent certification. First of all, a definition. I think it's really important to understand. Definition of inherent. What do I mean by that? Well, basically it means that the FR is in the panel, okay? It's existing in something as a permanent, essential, or a characteristic attribute. And the benefits of that, you can see the photograph on the top right is a picture of the OSB mat before we make the product. The FR chemical is added to every single one of those wood strands. It's not an afterthought. It's done very intentionally during production. We have a specifically designed FR addition system, which is top secret in our factory, to make sure that is applied to every strand in the board, which gives you a very good reaction to fire on the surface and also a good burn through of the product itself. And the other benefit of doing it in the factory is that we can impart certain essential characteristics or attributes to the product. So for example, if we want the product to be flame retardant, we can add a flame retardant. If we want it to be structural, we can impart those structural characteristics to the product. We can add a different resin to give zero added formaldehyde for no formaldehyde emissions, which is important for things like LEED certification and so on. So bringing a lot of different product attributes into play here, we can add during the process. The product is made in a continuous, controlled and independently certified way, and this guarantees the highest quality. So that's what I'm going to focus a little bit on in the later session. First of all, just to pick out a couple of key words from the CPR Annex 1, the Construction Products Regulation. So I'm not going to read through the slide. You'll get a copy of these slides afterwards, but please do take a moment to understand it if you haven't already. For a construction product, there are certain essential characteristics that product must have, and that's the reason I picked out this application of OSB in structural permanent use in construction. The CPR points out that construction works as a whole and in their separate parts must be fit for their intended use. It sounds obvious, but it really is important to point that out. There are 7 in total, ranging from the 2 I have here, things like noise, environment, safe use of products and things like that. I'm going to focus on 2. One is mechanical resistance and stability, and by that I mean the structural properties, and the second one is pretty obviously safety in case of fire. So what is the Declaration of Performance and CE marking all about? Well, if you haven't seen a Declaration of Performance, if you don't know what it is, it's literally a piece of paper. I'm going to show you what that is in a few minutes. But as a manufacturer, it is our responsibility to produce this document because, as I mentioned earlier on, wood panels are covered by a harmonized European standard, EN 13986. Having that standard means that we have to have a declaration of performance if we put a CE mark on a product. So what that DOP shall contain, without reading it, but very importantly, it has an AVCP, a verification of constancy of performance. And that basically verifies by a third party that we can do this repeatedly over and over again on every production cycle, every day, 365 days a year. It also relates to the intended use of the construction product. So yes, you can make a product Euroclass C or B, but it must be suitable for use in that construction application. So a floor, a roof, or a wall sheeting. Again, I'm going to look at this in more detail. And those essential characteristics, so how does that flooring product perform? It has to have certain strength characteristics and so on. If we do not declare, we don't have to declare certain properties, and if we don't test and declare those, then we put NPD on the document, and it's really important to point that out. A copy of this document should be supplied either in paper form or in electronic means. So if you go on our website, you'll find all of our compliance documents. Again, it sounds obvious, but a lot of companies out there do not produce a DOP, and if they don't, then they're obviously in breach of the CPR if they're producing wood panels. So it's really important to ask for that piece of information. In that DOP, we refer, and in our certification, we refer to something, a bit of a mouthful, assessment and verification of constancy of performance, AVCP. Again, just to point out the keywords here, it basically safeguards the reliability and accuracy of the declaration of performance. So we're declaring the performance of our product, but we don't have the final say. A third-party independent certifier does, in our case, Exova Warrington Fire. There are 4 different systems, 1, 2, plus 3, and 4. And basically ranging, they range and differ depending on the level of third-party involvement in that process. So for example, level 4, you can basically declare whatever you want and nobody's really going to check it or certify it for you. But in the case of flame retardant products, it's AVCP level 1, which is the highest class possible. And the reason for that is because you're looking at really important and essential characteristics of the product, and you're declaring an improved reaction to fire performance, and somebody needs to oversee that. Somebody needs to oversee that you're adding the FR in the correct way, and somebody needs to oversee your quality, production control, your factory production control, and somebody needs to sign that off and certify it. So again, I'm going to show you those documents later on. So just to give you a rare glimpse into our R&D, we're the only wood panel products manufacturer in Europe, and I don't know about the world, I'm not sure about that, but in Europe, with our own in-house R&D centre. We spent a lot of money on this. When we spent 60 million investing in our production plant at Smartply to make OSB, we chucked in another bit of money into an R&D facility. And basically what this gives us the ability to do is to produce very high quality lab scale prototypes. So R&D on a full scale production process is really tricky and really dangerous if you don't know what you're doing, and the production manager certainly doesn't like when we put things on the line that waste time and valuable production time. So what we do is we try everything in the lab first. We get it to a very, as I said, an early stage prototype. The photograph on the left is a lab scale blender from the same manufacturers as the actual blenders in the factory. So it gives a very repeatable and indicative panel. And then we basically press meter by meter panels in a lab press. And again, we can set this press to mimic exactly the production of the product on the main line. So again, indicative fire testing, we're still at the R&D stage. None of this is required of us at this stage. The first video here, again, I will show you the start, the middle, and the end. So on the left, you can see the flame retardant treated OSB, and on the right, obviously, the untreated one. And immediately when the flame is put on that product, the untreated starts to burn. So it's already ignited and it starts to burn. So again, I'll flick forward a little bit. 3 minutes into the test, you can see the untreated is really hotting up. And on the left, it is just basically charring. So this is the chemical reaction of the flame retardant additive with the heat. It basically forms the complex array of salts in the FR chemical, basically make the wood char, and char protects the wood behind it. So essentially, it just keeps doing that. So that's after 5 minutes. You can see after 4 minutes, you can see the untreated OSB has completely burned through. After 7 minutes, 8 minutes, 9 or 10 minutes. So you can see this will just keep going and keep going and keep going. So that's just a really, I suppose, a simple explanation or a visual on the inherent properties of the FR in the panel itself. That as the char layers eventually fall off, you're basically exposing more of the wood that is treated with the chemical. So again, we're still at the R&D stage, and just to highlight the importance of the structural properties, we have our own in-house structural testing lab run by a PhD qualified structural engineer graduate from Edinburgh Napier University in timber engineering. So again, just looking at everything, all of those essential characteristics of the product, from compression to racking resistance for timber frame walls, to panel shear for web stock I-joists, to 4-point and edgewise bending for different applications in flooring, roofing and wall sheathing. So that's at the R&D stage. Now, obviously, the critical stage is upscaling that into full-scale manufacture. So essentially what we do in MEDITE and Smartply is we essentially take in logs or wood chips from sawmills. We grind them down to strands in the case of OSB, or fibers in the case of MDF. We add resin, wax, and a series of other additives in there, depending on what particular properties we want to impart in the product, in this case an FR chemical, and we produce a range of panel products from that. Now at this stage, we have to start standing over what we're saying. We're gone from the lab, and this is full-scale manufacture. So now we're into factory production control. So this is basically the ongoing quality assessment, quality assurance testing to show our compliance with EN 300. This is a rolling testing in every shift during the production of our products, ranging from mechanical and swelling properties, such as bending strength, stiffness, deflection, swelling and thickness, and moving on to moisture resistant properties to show how resistant the board is to moisture. The most important test in there, and how we know we've got a good quality product, is the internal bond. The photograph on the right, which literally just the OSB sample is stuck to two metal blocks, and we essentially just pull it apart, and we measure the force required to pull that piece of OSB apart. So it measures how strong that the glue bond goes right the way through to the core of the board. So this is looking at reaction to fire, Euroclass system. The first test that you pass is the SBI, or single burning item test, and what this measures is the fire growth rate, the total heat release at a certain point in the test, and the lateral frame spread. It's often called the room corner test, and essentially what it is to replicate what happens if a waste paper basket catches fire in the corner of a room, and how the fire basically develops from there and spreads within the room. The next video is the ignitability test. As the name suggests, it just measures how easy or not it is to ignite the surface of the material. So it's a speeded up video, obviously. It's a 30-second duration test, with a flame applied at an angle at a certain distance to the piece. And the results of both of those tests go forward into our fire classification document. You must pass both tests to go to the next stage for certification. We do exactly the same thing for floors, slightly different. The same ignitability test, I won't show you that again. But the radiant test, this is a test specifically for flooring, and it's the example I'm going to follow through to the end. This is the burning behavior with a radiant heat source. So essentially what you have is a pilot flame, your sample, and a radiant panel then, which basically forces that pilot flame along the surface of the flooring product. So you can see the product is fed in, flame is put up to it, and the radiant panel there on the top pushes the flame along the sample, and we measure then the resistance of that piece. So again, you must pass both tests to get your fire classification. Moving on then to the STA, which is the Structural Timber Association. This is a totally different test method and set of characteristics for the product. This has nothing to do with the Euroclass, and there's often a bit of confusion about that. What I've just described to you is under the harmonized standard and the Euroclass. This is specifically to the Structural Timber Association for timber frame buildings during construction. So without going into detail, all we're talking about here is if you're building a timber frame building beside an existing building, you have to be a certain distance apart. You have to keep your building a certain distance away from the existing building, depending on the level of flame retardance of that building. So essentially, the more FR products in that building, the closer you can put it to the existing building. So that's where the separation distance comes in. And this is where I suppose it all came from. This building in Peckham in 2009 was really, I suppose, the turning point for the industry. A timber frame, untreated timber frame building which caught fire and essentially was so close to the buildings beside it that it set fire to existing row of apartments across the road. So it's a rhetorical question really there, and obviously FR products, the more FR products you put into that building, the more you will increase its ability and the more you can get those buildings closer together and reduce your fire risk. Arson is the most common cause of site fires. This is how they start. So this is just a clip from the STA document, and it specifically says how to test for this, to set up the sticks for this particular test. So if a thug has to go on a site to burn a building intentionally, this is typically how they do it. They use offcuts from the building site. They'll throw some petrol on it and maybe something to get it going. We're back in the R&D stage. This is when we were testing the product. So it's a 40-minute test, and a test starts at 2 minutes. The accelerant is allowed to soak into the product for 2 minutes before the fire is started. The initial stage of fire development. This is the most important stage of fire performance of materials, at the early stage, and you're preventing the material from igniting in the first place. So what happens is the chemical reaction between the FR additive and the OSB forms a char layer and essentially prevents the OSB from burning, cuts off additional fuel to the fire. So in an untreated OSB product at this stage, or way before this stage, it will have burnt through the OSB completely and you're into your structure. So the critical point here is that the charring has protected the OSB, the fire doesn't penetrate the OSB, and the fire eventually goes out. We did this room corner test in a BRE in an SBI rig. The next stage of that, you pass your ignition test, you do a small room test as it's called, and this basically measures the heat flux, which is the heat energy output, and the flame spread and the burn through. So it's essentially a small room built up in timber frame with a fire starter and a crib in the corner. And for this test, we were testing the FR build status of our flooring product. So you can see the fires are basically attacking the underside of the floor. The important point to note here is this radiant panel here on the left-hand side. That is measuring the heat flux at a certain distance from that window aperture. And you need to be below a certain threshold for that to achieve FR build status for your product. So if you pass your ignition test and your room test, then you can call your product FR build, and that is a specific requirement of the STA. Just a brief word on CE marking, just before I go into the specifics of it. Basically, a definition of invalidate, if you look at what that means, is to deprive an official document or procedure of legal validity because it contravenes a regulation or law. Okay. So just to bring that into real life, what we have here is an example of a panel marking on a sheet of OSB, which is normal OSB 3, untreated, not flame retardant. You can see the CE mark and various pieces of information in there saying that it's for structural use. And here's how it can be invalidated. So basically, by applying a flame retardant chemical to a CE mark product can invalidate the CE mark, but not always, even though it often remains visible. So if somebody takes our takes our OSB 3 and then post-treat it, then there's a number of things you need to do to make sure that product still maintains that CE mark. Products which have a CE mark applied prior to treatment will require a new DOP to be issued after treatment to declare the improved reaction to fire performance and any change of non-fire, for example, structural properties that may have occurred through the process of treatment. And that's called out in the CPR under AVCP System 1. Not all wood-based panels are suitable for impregnation process due to swelling and strength loss with some types. So you can imagine pressure impregnating or flooding an OSB panel or a plywood panel with liquid. The OSB isn't designed for that in the first place, so you do need to take steps to re-CE mark after that. So essentially, do not accept company-branded literature, as this will not prove compliance on its own. And the above extracts are from TRADA Wood Information Sheet on flame retardant treatments of timber products. So it's not us saying it, this is obviously what's coming from the CPR and the requirements of manufacturers of post-treated products. So I'm just going to go into a little bit more detail now to finish up on panel markings. This is just an example of a panel mark, again, on a sheet of OSB. Product manufacturer must be shown, FSC certification if it has it, and the CE mark. So that's the CE mark, and that's the information that goes with the CE mark. You can see the level of information that's on there. The first step is the technical data sheet. So this is basically not a compliance document. It's literally a sales promotion guide. It gives guidance for specifiers on our products. It gives you a little bit of information about the product and the performance claims that we make for that product. So for example, as you can see in the CE mark, we're claiming Euroclass C and B for flooring, and that document will state that, and it will show the compliance documents. The next step, and this is the most important bit that I mentioned earlier on, this is the declaration of performance. So what that is, it's again, as I mentioned earlier on, it's a legal responsibility under the CPR when we apply a CE mark. There's a declared performance relevant to the intended use, for example, timber frame, or for example, flooring, roofing, or wall shielding. The harmonised standard EN 13986 is for wood-based panels for use in construction. That's its title. And this is the most important document. So you need to get your hands on this document and scrutinise it. In there, if I could open it up, it would show basically the DOP reference number, the AVCP level 1. It will show all the structural properties that we have in there, and it will show the reaction to fire that we're claiming. But that's not it. That's our responsibility as a manufacturer. We have to provide that document as a legal requirement of the CPR. Still, there's another document that you need to satisfy that you've done that. This is one of them. This is the fire classification report. So we make these available. These are the individual test reports for each specific product in each specific application. So it's product specific, it's application specific, and basically this cannot be accepted as a compliance document. It is just a test at a point of time. It needs to be overseen by a third party. And that third party then verifies that, and this is the document called the Certificate of Constancy of Performance. Again, a bit of a mouthful. What it is, it's issued by our notified body, Exova Warrington Fire. It's independent certification. It safeguards the reliability and accuracy of the declaration of performance that we've issued. The CE mark is printed on the certificate and the product. The certificate must be shown on the DOP. The fire test reports and classification report must match. And the AVCP System 1, which is the highest for FR treated products, must be mentioned on that document as well. So all of this ties in. The DOP matches in with the Certificate of Constancy of Performance. And then further certification, which is not linked to the CE mark, but is obviously important for the STA, the Structural Timber Association FR build, and that is the WPA FR benchmark certification. So again, it's not part of the CE mark. It's independently qualified quality scheme for wood products treated with flame retardant chemicals. The certificate of conformity covers inline treatment process for FR product range. So essentially, the WPA auditor comes to our factory and basically oversees how we add the chemical and certifies that we're doing it, that we know what we're doing, and we're doing it in a repeatable way. And then finally, there's one more piece of certification from the WPA, and that is similar to the first one, but this is specifically to do with the FR build benchmark certification. Again, it's not part of the CE marking. It's independent, and it basically relates to our FR wood products treated in the factory to do with the STA requirements, and it minimises the risk to life and property during the construction stage. So this is an important document if you're looking for FR build certification for timber frame. It doesn't certify our FR partner Zero Ignition. They have their own certification for the chemical itself and are members of the Wood Protection Association. The certification only covers the production of FR products. It does not cover the testing of those products in use. That's a separate piece of testing, which is the STA testing. So the ignition test and the room test is part of the certification and testing that we go through as part of the STA. So finally then, just to recap, I suppose, to summarise and give a couple of recommendations. If you haven't already, read the CPR. It's a fine read. But if you haven't, do take the time to do it. You will see things in there which will shock and surprise and amaze you, and it'll make you think about your responsibilities, whether you're a manufacturer or a distributor or a reseller or an architect or an engineer or other specifier. Upskill your workforce. I can't stress that enough. Ask for a CPD from a product manufacturer or other independent body. Days like this are great. Inform yourself and your workforce. Also inform your supply chain. So you've got it clear in your head. You understand what your requirements are. Also understand the requirements of everybody else in that supply chain. So if you're an architect and you're specifying a product and you specify a Euroclass B, make sure that everybody in that supply chain knows that that product must get used on site. There's no point in specifying something and then the contractor goes into the builder's merchant and buys a different product. You need to make sure that the products get all the way through. So what's been specified is actually gets used on site. Again, I can't stress the DOP enough. It's the legal document. Check the DOP. First of all, ask for it. If you can't get your hands on it, you should be able to. The manufacturer has to provide it. Check it, and check it for both fire and structural performance and any other performance if required. Ask for full evidence of certification. So the DOP that I just referred to, the classification documents, and the certificate of constancy of performance. And never accept a pressure impregnated wood panel without a valid DOP declaring structural properties after treatment. So again, this is relating to structural use in building where you need flame retardant properties and structural properties. Thank you for your attention.